Hi, I'm Andrew Dichenko, and today I'll be presenting our paper, Cascaded Multilingual Audiovisual Learning for Videos, which has been accepted to Interspeech 2021. This is joint work with the following authors. We explore self-supervised audio-video learning from instructional videos, which contain visually rich descriptive language. We use the AVLNet model to learn a joint audiovisual embedding space from the raw audio and visual channels in instructional videos. Our goal is to learn from the raw speech audio instead of text from automatic speech recognition systems for several reasons. There are over 7,000 languages spoken worldwide, but automatic speech recognition is only supported for less than 2% of them. Automatic speech recognition makes errors for audio with background sounds, reverb, and accents, all of which are found in instructional videos. Also, learning from text misses the opportunity to learn from visually relevant non-speech sounds. The AVLNet model was trained on the How to 100 million dataset, which contains 1.2 million instructional videos. It could successfully perform audio-video retrieval on the UCook2 dataset. Next, I'll present some audio-video retrieval results on UCook2 using AVLNet. The model only uses raw audio as input to retrieve similar visual clips without using text.
All right, so here's my flour mixture. I'm just gonna add in some salt and some black pepper. You gotta have black pepper. Yes, yes, yes. Lots of black pepper and some celery salt, just like.
In this example, the input audio query mentioned ingredients like flour, salt, and pepper, and the top 5 most similar visual clips all show similar ingredients. This shows that the AVLNet model can recognize spoken words and relate them to relevant visual content in videos. In this work, we're interested in learning representations for videos in other languages. However, there are several challenges. While there are many instructional videos available in English, there are not as many available in other languages. For example, there could only be hundreds of thousands for Japanese and only thousands for a low resource language like Igbo. This is important because we find that hundreds of thousands of videos are necessary to learn strong representations. Even if there were large-scale datasets of videos available for all languages, it would be challenging to download and process them to train models given the significant engineering effort required. Therefore, in this paper, we propose a cascaded approach to learning multilingual representations. We use the AVLNet model trained on English videos and apply it to audiovisual data in other languages. We test this approach on Japanese cooking videos and spoken captions of images in Japanese and Hindi. In both cases, we find that retrieval performance significantly improves compared to training only on the Japanese or Hindi data. We call this a cascaded approach because the model learns from one language at a time. For example, first English videos and then Japanese videos. We collected a dataset of Japanese cooking videos. We call it YouCook Japanese to indicate the similarity in size and style to the English YouCook2 videos. We consider the same task of audio-video retrieval, where the input audio queries are now in Japanese. In this figure, we show example zero-shot retrieval results of the AVLNet model trained on English How to 100 million videos and evaluated on the YouCook Japanese videos. We show the audio, Japanese text transcripts from an automatic speech recognition system, and the English translation. Even though the model has been trained only on English videos, it can still perform retrieval surprisingly well using natural sounds, such as sizzling and microwave beeps. When we fine-tune the model on the Japanese cooking videos, the retrieval performance improves. We can see that the model can handle more complex audio queries in Japanese and retrieve video clips with specific ingredients mentioned in the queries, like cheese, chicken, and cabbage. We also use our cascaded approach to fine-tune the AVLNet model trained on English videos on spoken captions of images in Hindi and Japanese. Here we show an example image with the spoken caption in Hindi and Japanese, as well as the corresponding output from an automatic speech recognition system, as well as the English translation. We find that our cascaded approach significantly improves performance on audio image retrieval using the spoken captions in Japanese and Hindi. To summarize, we proposed a cascaded approach to learning multilingual representations by using the AVLNet model trained on English How to 100 million videos and applying it to audiovisual data in other languages, such as videos in Japanese and spoken captions of images in Japanese and Hindi. We collected a dataset of Japanese cooking videos called YouCook Japanese, which is similar in content and size to YouCook2. Our cascaded approach significantly improves performance on both audio, video, and audio image retrieval. The project resources will be released at avlnet.csel.mit.edu. Thank you for your attention.